Bismillahirrahmanirrahim. This is Abdurrahman Kahi and you are watching Animals Production Practices. In our today lecture we are going to talk on the milk quality analysis. The milk analysis are how to check the quality of the milk. Under circumstances should milk be shaken very violently since viscosity does not allow air bubbles to rise easily. Moreover, agitation of the milk tends to churn with the result that even distribution of fat becomes difficult. When milk from an individual animal is to be sampled, the whole amount of the milk is taken and a sample drawn from the middle of the vessel containing it. For usual analysis of the milk, collect 250 to 500 ml of the sample in a wide-mouthed bottle. When sample is only to be collected for carrying out the first test, the only 50 to 60 ml would be sufficient for the analysis. Fresh samples of the milk should be examined since important changes in its physical condition, chemical composition and bacterial content may take place even within a short time. When samples are to be sent some distance to a laboratory for examination, they should be first preserved by the addition of certain preservatives. 20 drops of formalin to a liter of milk or half a gram of potassium dichromate to a liter of milk is enough for this purpose so that the preservation of the milk can be done. The milk should better be sent in a previously sterilized bottle closed by a sterilized stopper. For bacteriological examination, antiseptics and preservatives should not be added. However, for examination, general appearance, odor, color, consistency and the taste of the milk should be observed. Milk when freshly obtained is a white, opaque fluid when seen in bulk. It has a characteristic faintly sweetish taste and peculiar odor. Sweetness is due to its lactose content. The so-called coy odor is due to manure gaining access into milk and due to the absorption of the characteristic odor from the atmosphere of the dairy sheds. The white color of the milk is due to the calcium caseinate content and the opacity is due to the same substance and the fat. Sometimes a more or less yellowish tinge is noticeable. That is due to a pigment lactochrome associated with the fat. It is yellowish in cow's milk. Due to colostral period and near the end of the period of lactation, milk may acquire saltish or bitter taste. The development of bitter taste in milk is in late lactation is due to the activity of lipase enzyme which hydrolyzes milk fat. Abnormal odors can be due to diseased odor or the growth of the bacteria in milk. However, under certain aromatic feeds also impart a characteristic odor and the taste to the milk such as rape, cabbage, beets, turnips, carrots, etc. Among the wild plants, the garlics have such strong inoiny flavor. Take immediate steps to eradicate all such plants from the feed of the milch animals. A blue tinge in milk may indicate a low percentage of the fat due to either skimming or watering. The amount of dirt in milk can be carrier of the bacteria. Moreover, visible dirt is an indication of the care exercised in milk production. For descriptive purposes, the following schedule should be useful. General appearance. Note whether clear or any visible dirt or foreign matter is present. If so, describe its nature. Odor. Record odor as normal, none, very mild or strong. Coy, manure like, fishy, turnipy or onion. Heat the samples of the milk to 60 degrees Celsius and note the odor by smelling. Heat accentuates any undesirable odors present. Color. Note the color and record it as sample white, yellowish, light yellowish, reddish, bluish. Describe any abnormal color, what it may be due to. Consistency. Record consistency as normal, watery, thick, slimy or shredded. Physical examination of the given samples, observing their color, odor, consistency and the sediments. Here the three samples can be enlisted and their appearance, odor, color and consistency and sediments may be drawn. Determination of the specific gravity by lactometer. A lactometer is a hydrometer specially made for the testing of the milk. The instrument is based on the fact that when a solid body floats in a liquid, it displaces an amount of the liquid equal in weight to the weight of the floating body. Lactometer consists of a long, narrow, graduated glass stem which is enlarged below into a hollow glass bulb weighted with mercury and lead shots. Numbers registered on the lactometer scale range from 10 or 15 to 40, which record quinines degrees. Apparatus: lactometer, cylinder, thermometer. This is the simple lactometer. And here how can we use the normal lactometer for the purity test. Determination of the specific gravity by the lactometer. What is the procedure? The given sample of the milk is thoroughly mixed and brought to temperature between 10 to 21 degrees Celsius. It is then poured into a high glass cylinder by its sides and the lactometer is slowly lowered into the fluid until it floats. There it is allowed to remain in position for about half a minute. The lactometer must not be allowed to touch the sides of the cylinder or its bottom. When it becomes stationary, one records the scale reading and the temperature. Determination of the specific gravity by lactometer is still continued. If the temperature is above or below the standard, the lactometer reading is corrected according to the following rule. Add 0.1 to the lactometer reading or 0.0001 to the specific gravity for 1 degree Fahrenheit above 60 degree Fahrenheit. Subtract 0.1 from lactometer reading or 0.0001 from the specific gravity for every 1 degree Fahrenheit below 60 degree Fahrenheit. The specific gravity of the sample of the milk is then calculated by dividing the quinines degree by 1000 and adding 1. For example, if the lactometer reads 31.9 at 60 degree Fahrenheit, for example, if the lactometer reads 31.9 at 63 degree Fahrenheit, the corrected lactometer reading becomes 31.9 plus 0.3 or 32.2, and by further calculation specific gravity equals 1 plus 32.2 over 1000 or 1.0322. This is how can we correct the simple specific gravity calculated by lactometer reading. Determination of the acidity, percentage acidity in the milk. First one, titration. Equals volume of the acids and alkali of the same strength will exactly neutralize each other. Acid and alkali will of the same strength will exactly neutralize each other. The point of neutralization is determined by the means of an indicator. It gives one definite color in an alkaline medium and another color in an acid medium. The indicator generally used is phenolphthalein, which is colorless in acids and pinky in alkali. In finding the percentage of the acid in the milk, it is necessary to know the weight of the milk taken and the strength of the alkali solution used. This is the titration of an acid with the base using phenolphthalein indicator. In the figure 1, you can see the determination of the percent acidity in the milk. The weight of the milk by the balance or by multiplying the specific gravity of the milk by the number of ml of milk taken. The strength of alkali used in tenth normal or decinormal expressed as n by 10. 1 ml of n by 10 alkali solution would just neutralize 0.009 gram of the lactic acid. To find out the percentage of the acidity in the milk when n by 10 alkali is used, the number of ml of n by 10 alkali necessary to neutralize the acid in the amount of the milk taken is multiplied by the 0.009 and the product is divided by the weight of the milk taken in the grams and the quotient multiplied by 100. This is the formula description of the determination of percent acidity in the milk. What is the formula? Number of the ml of n by 10 alkali used multiplied by 0.009 over weight of the milk in grams multiplied by 100. This is the percentage of the acidity in the milk formula. Now here the example has been solved. And what could be the apparatus and reagents? Burette with the clamp and the stand, pipette, alkali solution, phenolphthalein solution. Determination of the percent fat in the milk. This is can be done by the Gerber method. Gerber method. What is Gerber method? It is invented by the Gerber method is invented by the Dr. Gerber, a Swiss scientist. With this method, the milk fat is separated from the milk by strongly acidifying and rotating the milk in a specially constructed Gerber's acid butyrometer in the Gerber's centrifugal machine. This is the simple 10 ml of the sulfuric acid are drawn up into the acid pipette and run into the test bottle. Then slowly add 11 ml of the milk by carefully letting it flow down the side of the bottle so that it will not mix with the acid. Finally, 1 ml of the amyl alcohol is added carefully so that in the end of the three fluids float in three distinct layers. The rubber stopper, dry and with no cracks, is then carefully inserted. The fluids in the bottle are mixed by slowly inverting the bottle one way after the other until a transparent solution is obtained. The bottles are placed in the machine with the void stoppered and near the circumference opposite each other in order to maintain the balance, and wheeled for 3 to 4 minutes at the rate of 1000 revolutions per minute. The fat collects in a clear yellow column at the top of the neck. These are the formula description of the total solid and SNF calculation. Total solid and solid not fat in the milk. Where CLR is equal to lactometer reading corrected to 60° Fahrenheit, just like earlier slides we have described in detail it, and then percentage of the fat. That's about all today. lecture. Thanks, first of all, thank you very much for taking your time and watching this lecture. If you are having any question, you may ask in the comments. Please like, comment, share and subscribe my channel. Thank you very much. Allah Hafiz.